The very first thing you'll notice in chapter 3 is we did what's called literal equations, everyone's favorite. Literal equations is where it gives you all variables and it wants you to solve for a specific one, okay? And this is just one of many examples. In this case, they wanted us to solve for A. So basically what you're doing is you're treating that A like the X that you would solve for in any equation that has numbers. What would you do with the numbers if you were trying to solve for that variable? So if R was a number, well, it's plus R. I would subtract R, all right? And then you have H minus R equals A times B. Well, if B was a number, what would I do? It's being multiplied by A. Well, I'm going to divide to get it across. So I'm dividing both sides by B. And then you can see that you have your variable by itself. The more difficult ones are the ones that have two of the same variable. And with those, you're really just trying to get both of those variables on the same side and then use distribution where you can pull it out so that you have it by itself and can divide by a group. But just look at it as though the one thing you're solving for is your variable. The other ones, how would you treat it if they were a number? All right, so that was literal equations. So solving proportions, you are going to use cross multiplication here. It does not matter if it has a number or a group. You're still going to use cross multiplication. All right, you're going to multiply top left to bottom right, set that equal to top right to bottom left. If any of those have like a plus or minus in it, you must put parentheses around them so you can distribute. So if you look at your sheet, if you look at like 67, 68, those have an x plus 2 or an x minus 2. Go ahead and do this same method, but just make sure you put parentheses around those. You can always put parentheses around them. It's just to remind yourself because you will have to distribute if it has a plus or minus in there. The next thing we did was similar figures in solving proportions. We used ratios then to solve similar figures. So similar figures are just a set of ratios. So like for this one, you'll notice that 6 over 9 equals 4 over 6, which is going to equal 3 over 4.5. Okay, so for similar figures, if you're missing one of those, just put an X by what you're missing. So if you have a question mark on your similar figures, you're going to make that question mark into an X. And you would say, well, I know that 6 over 9 should equal 4 over 6. And then you can do your cross, or well, in this case, if I said there's an X there, we'll just pretend we didn't know that was a 6. And you're going to use your cross multiplication to solve, okay? Now, pay attention to the order and make sure they're in the same order because sometimes the orientation will be confusing, okay? This is where you may want to have highlighters. So if I were to look at this particular one, I would say, well, A to B should be D to E. So A to B, this guy, should be on top of D to E. It's in the same order, okay? And then B to C, well, that should be correspond to E to F. So B to C should correspond to E to F, which leaves, of course, A to C corresponding D to F. So pay attention to the order that they have given you those similar statements because you can't just look at it and assume which side goes with what. You want to color code it so that you know which ones to put on top of each other. Because if you put the wrong ones on top of each other, you're going to get the wrong answer. If I have something like this, 62% of 35 is what? These are also percentages, but these aren't necessarily percent increase, decrease. They just want to know what you're solving for. Remember, of means multiplication, is means equals. So then you're just going to set up an equation. 62%, well, how do I write that as a decimal? 0.62 times 35 equals what? I just have to multiply. If my variable's on the other side, I would divide, okay? So you're literally just interpreting these into an equation and then just solving. Remember, you could also do these by part over a whole. So of always represents your whole. Your part, well, that's your X. That will always equal your percentage over 100. And you could also cross multiply to solve as well for these. Okay, so you could set them up like an equation, or you can set them up like a ratio to solve. Right. We also did percent increase and percent decrease on this one. So, and next major section was percent increase, decrease. It is always the subtraction over the old value, the original value, okay? So this is where I have the most mistakes for percent increase, is that I have you putting it over the wrong value, okay? So you subtract the two, and you can even, you'll notice it's the same exact formula. You subtract them, and you put it over the old value. So if you want to think about it this way, you don't even have to worry about which one you put first. You can always put the bigger one first if you want to. Just do absolute value here, because you're going to tell me increase or decrease, all right? You don't have to say positive or negative here. For the ones where it gives you a problem, like 62% of 35 is what? So that's in the same kind of section here. Distance, rate, and time. Distance, rate, and time. It shows 4 different equations, but you really only have 2 types. You basically have a type where the distances equal each other, or you have types where they are added together, okay? So if you have 2 cars going in the same direction, those distances will be equal. So here, your distances will be equal to each other. If you have a car that is leaving and coming back, this third one, again, you'll see that they started, left, came back, same distance. So when they leave and come back, those distances are also the same. The other 2, opposite direction, they start at the same point, but they go different directions. Those distances are not necessarily the same. For this particular one, your 2 distances will add up to equal the total distance apart, okay? Total distance apart. And the same is true of this last one. If they're headed towards each other, once they meet, those 2 distances again will add up to equal the total distance they started out apart. So when you're reading these problems and you see the total distance apart was this, that should trigger, oh, I'm probably going to add their 2 distances together. When it says, how long did it take him to catch up? How many miles did it travel for the trip there, or whatever back? Then you're going to look for, oh, they equal each other. So catching up with somebody, starting at the same point, catching up with them, that's going to be equal. Going someplace and coming back, equal. But if they start and go opposite, or start and meet in the middle, then it's going to be adding them up. Okay, so those are your 2 basic types. The formula for all of them is exactly the same. Your rate times your time equals your distance. So when we did this, we would set up a chart. Person 1, rate time equals distance. Person 2, rate time equals distance, okay? And then you're deciding, do I add their distances or do I set them equal to each other? And then you're just solving your basic, what we've already done, equation solving. So when I'm doing these, I am going to set up a chart for these. And I am going to say, well, I have one traveling, I have a second one traveling, and I'm going to set up a rate, a time, and a distance, okay? So very often, like in this case, on number 88, we have Ryan traveling and we have May traveling. We want to figure out their rate, their time, and their distance here, okay? They traveled in opposite directions on this one. So this is one where we're going to add them up. All right. And we're going to fill in what they know. May traveled 40 kilometers for 3 hours. They just told us both her rate and her time, okay? It says that Ryan left 1 hour before her. That means he traveled 1 more hour, which means he traveled her 3 hours plus 1, 4 hours. We're finding his speed, which means we do not know this one right here. And then you just multiply across. 4 times R. 3 times 40. All right? When it is opposite direction, you add them. 4R plus 120 equals the total distance apart, which they tell us in the problem is 420 kilometers. And then we are going to solve. Subtract your 120, divide by your 4, and then you will get your rate. Now, mixtures can mean, he's selling, premium peanuts that are made of almonds and, pecans or whatever, okay? Or it can say saline solutions, whatever. And so when you set these charts up, you want to name them, whether it's solution A, solution B, or whether it's almonds and walnuts or whatever it was, okay? And then you want to decide what percentage am I talking about, okay? So you have this certain amount here, and your two amounts should add up to your total amount. Then you have your percentage of each amount. Now here's where it's important. If it's percent of saline, you need to write percent of saline. Because if it says pure saline, you're gonna write 100% there. But if it says pure water, you're gonna write 0% there because you're talking about percent of saline, okay? So it's very important when you label it for your own brain to remember what you're doing, that you say, okay, this column is what percent of this do I have, okay? And then this column here, this third column, always multiplies across. How much I have times the percentage. That's going to equal this column. This column will also add up. The total amount of the first guy plus the second guy should equal the total amount of everything. The column that does not add up is this percent column, okay? It does not add up. Your percent of your first solution, your percent of your second solution, and your percent of your final, they don't add up. Sometimes that's where an X is going to be. What is the percentage of your final solution? So wherever you see the what or how much, that's where you're going to put your variable in this chart. So if it says how much of an 18% solution will you need, or how much of the initial solution do you need, or what will the percentage be of your final solution. So you're going to read those words to see where is the thing I am trying to solve for in this chart. That's where my variable is going to go. Your final solution here is going to come from this third column, just like in distance, rate, and time. This 0.220x plus your 0.15y, which in our case we're going to have x and x, equals your 0.9. Okay, so these two are going to equal this third guy. And that's how you're going to finally solve this when you get one of these, okay? So you're going to have to set this chart up, and then the first box plus the second box equals the third box here to solve for it. All right, so I am once again going to set up a chart. This chart's going to look a little bit different than my distance, rate, and time. For this one, I am going to have, the header there, but then I'm also going to have two things that are being mixed together to add a final mixture. I am going to have a measurement and then a percentage and then a total of the percentage that I have. So in this case, the two things that I'm looking at are brand A fruit punch and brand B. So those are the two titles that I'm going to give this. Brand A and brand B. And then this will always be my mixture, whatever that is for this particular problem. In this case, a fruit juice, mixture of fruit juice. I am talking about liters here. So liters is what I'm mixing together. And the percentage is percent fruit juice. And so this is going to be liters of fruit juice. This is just combines those two. So if I look, I'm going to read, she mixed 7 liters of brand A. 7 liters of brand A. 3 liters of brand B. All right, this first column always adds down. So 7 plus 3, I have 10 liters altogether. Brand A is 20% fruit juice, so that's 20% fruit juice. Brand B is 30% fruit juice. What percent is the mixture? Remember, that column does not add down. That's where my X goes. And then I'm going to multiply across. I'm going to say 7 times 0.2. 3 times 0.3 and 10 times x, all right? And then I'm going to add down. These two add up to equal this one. So 1.4 plus 0.9 equals 10x. All right?
This is 2.3 equals 10x. So x equals 0.23. I am looking for a percentage. So to find the percentage, remember you multiply that decimal by 100. That's 23% fruit juice is what that's going to be.
Chapter 4, we started with inequalities. All right, so solving multi-step inequalities is very much like solving equations. You're going to distribute if you have any parentheses. You're going to collect your terms, meaning put your variables on one side, your numbers to the other. This says move your variables to the left-hand side. It actually doesn't matter. If you always want to move them to the left-hand side so that you do it in the same order, that's perfectly fine. Me personally, I move them to where I don't have a negative, but that's just me. Sometimes you can't avoid the negative anyway. Move the constants to the other side. So if you always move your variables to the left, move your constants to the right, and your last step is going to be to divide. Now remember, the only difference between equations and inequalities is if you divide by a negative, you flip your sign. So if the number with your variable at the very last step is a negative, when you move that over with division, you're going to flip that greater than less than sign, okay? That's the only difference between an inequality and an equation when you're solving, all right? You will have to graph these. Remember, if it is or equal to, you have that closed dot. If it is just greater than less than, you have an open dot. And then you're telling me, is my x smaller than that number or bigger than that number? All right, and most of you did really well on the graphing of these. So the graphing wasn't difficult. Just watch your positives and negatives as you distribute. Watch your positive and negatives as you divide. All right, and then you're going to treat it just like an equation.
So I'm going to distribute this 5 through. I'm going to say 5 times negative 7, 5 times n. All right. I'm going to add the 35 to both sides just like I would. 5n is less than or equal to 75. Then I'm going to divide both sides by 5. N is less than or equal to 15. You'll notice it is a closed circle, or equal to. I started at the 15. Everything less than is what I shaded.
So we have absolute value equations first, starting on page 13. All right, absolute value equations. Before you set up those two, you have to get your absolute value by itself, okay? So this is where most of you had problems solving these. You must, it says isolate the absolute value. That means get rid of this 11 first, okay? Move that 11 over first. This is when you see the absolute value isolated. It's all by itself. There's not a multiplication. There's not an addition or subtraction on the outside of it. The absolute value is by itself. At this point, you can set up those two equations, all right? You're taking what's inside. Your absolute value is not part of the solving, okay? What's inside equals the 11. And then the second one is what's inside equals negative 11. Because its absolute value, it could equal 11 or negative 11 on the inside. And the absolute value would still be 11, right? So we're going to set up two equations of what's inside. What's inside equals the 11. What's inside equals the negative 11. And at this point, you have pretty simple equations to solve. Subtract your 5, divide by negative 2. All right? But you'll see you get two answers here. For absolute value, you will always have two answers unless right here it, for some reason, equals 0. Because then 0 doesn't have a negative, right? Or if here you equaled a negative number, then we'd have a problem. But standard absolute values always have two answers for your absolute values here. You can actually check these because you can plug those answers in all the way up here and you will get a true statement if you did it correctly. So you can check these as well. Basically, these are very similar to absolute value equations, all right? I did not give you any where you have to manipulate the outside first. We'll do that in Algebra 2, okay? So you are setting up two inequalities for every single one of these. What's inside is less than or greater than exactly how it gave it to you. Exactly how it gave it to you. You're going to set that up. Then you're going to say what's inside. You are going to flip your greater than less than, and you're going to change this guy to negative. So on the equation, you just change this guy a negative, right? But on this one, you also flip this inequality. Remember, if it's less than, you're going to get an and situation where you, on your graph, they should go towards each other. They should cross over. It should be in between two numbers if it's a less than, okay? If it's a greater than, you're going to have where they go in opposite directions, an or situation, all right? So if it's less than, you're going to have an and, where you should have them in between two numbers. If it's greater than, you're going to have an or, where they go opposite directions, okay? But it's going to be set up very similar. Exactly the way it gave it to you, then flip your greater than, less than, and flip your positive, negative.
If you have a less than when your absolute value is by itself, it is and. If you have a greater than, it is an or problem, okay? So if you have a less than, they should cross each other. If you have a greater than, they're going to go different directions.
Graphing, very, very simple. X value moves you left and right. You'll see 3, 3. I moved right 3, up 3. Negative 2, 4. Left 2, up 4. 0, negative 3. Didn't move at all, then went down. Okay, the only thing I still saw you struggling with are your quadrants. This is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. This is my x-axis. This is my y-axis. So for this point, where would you tell me that is located? You would say y-axis. You would not say quadrants 3 and 4. No, it's on the y-axis, okay? So if it lands on a line, one of those main ones, x or y, you're going to say x-axis or y-axis, okay? And then the other places, just watch where those coordinates are. Also did domain and range here. Domain is your x values, range is your y values. There's a multitude of ways it can ask the same question. It can give you this guy right here, and you literally list your x's and y's. 1, 2, 3, 4, 5, and 6 are my x's. My y's are negative 1, 0, 1, 2, 3, and 6. Those are my range or my y values, okay? It can ask for a mapping diagram, domain and range, and then you're going to draw your numbers with arrows to and from, okay? And then you have to tell me, is this a function? Is it a one-to-one relationship? Yes or no? It could also give you a function and say, here is the domain, what is the range? Plug it in, solve, tell me your y values. The only problems I saw there are positive, negative issues, just solving, okay? The last thing we did is to figure out what the function is. Function rule, given a list of x's and y's. And so remember for this, you're going to say, well, how am I going from my x value to my x value? Well, that's just adding 1. How am I going from y to y? I'm adding 2, okay? So 2, remember we put my y over my x. So 2 is the first thing I'm going to look at. Can I multiply by 2 and get this answer? So if I take my x and I multiply by 2, does that work? And so I'm going to look and say, does that work? 1 times 2 is 2. 2 times 2 is 4. I did not get what I needed, right? I needed a 3 here. I got a 2. So now I'm going to say, okay, so if I multiply by 2, I get this row here. I still need to get this final outcome. That's what I'm looking for, is this final outcome. So now I'm going to compare this row to that row. And I'm going to say, oh, well, if I just add 1, I get my answers, right? 2 plus 1, that gives me 3. 4 plus 1 gives me 5. 6 plus 1 gives me 7. I am where I need to be. So now I know that I have to not only multiply by 2, but I also have to add 1. So I know my final function rule looks like this guy right here.